Imagine opening an app, choosing a destination, stepping into a small aircraft, and taking off without touching a steering wheel, a joystick, or a throttle. No runway, no pilot sitting in front of you, no airport terminal, just a quiet electric aircraft lifting straight into the sky while the traffic below stays frozen on the road.
China unveiled its latest flying car. This is not science fiction, it's reality with cutting-edge design.
For decades, that sounded like fantasy, something promised by movies, tech expos, and billion-dollar concept videos. But now, in China, that fantasy is starting to look much more practical. And the most important part is not just the flying car itself. The real story is bigger. China is trying to build an entirely new layer of transportation above its cities. Not just cars, not just drones, not just helicopters, but a low-altitude transport network where people, cargo, emergency services, tourism companies, and eventually commuters could use the sky like a road.
This is the first flying car in the Southern Hemisphere to be displayed in China.
And that is why the world is paying attention. Because if China succeeds, the next transportation revolution may not begin on the highway. It may begin 300 feet above it. Before we go deeper, hit like and subscribe if you want more premium breakdowns on future technology, transport, and the global race for innovation. Now let's look at what China is really building and why this may be one of the biggest mobility shifts of the next decade. For years, flying cars had one major problem. They looked amazing in demonstrations, but they rarely made sense in real life. A car needs wheels, suspension, crash protection, headlights, mirrors, doors, and road safety systems. An aircraft needs lift, balance, lightweight materials, rotors, batteries, emergency systems, and strict aviation approval. Try to combine both into one machine, and you usually get something that is too heavy to fly well and too awkward to drive well. That is why many flying car concepts looked exciting on stage, but disappeared before reaching normal customers. China's newer approach is different. Instead of asking, can one machine do everything? Companies are asking, can different machines work together? That is what makes XPeng AeroHT's land aircraft carrier so interesting. It does not look like a normal car with wings. It looks more like a futuristic six-wheeled ground vehicle carrying a separate aircraft inside it. The ground vehicle handles the road. The aircraft handles the sky. That sounds simple, but it solves one of the biggest design problems in the entire flying car industry. You do not need the road vehicle to fly, and you do not need the flying machine to drive through traffic. Each part can be built for its own job. The carrier vehicle can transport passengers, equipment, and the folded aircraft to a suitable launch area. Then the aircraft can deploy, unfold, and take off vertically. This matters because flying vehicles do not just need to exist. They need to fit into real life. Where do you park them? Where do you charge them? Where do you launch them? How do you transport them when flying is not allowed? A modular design gives the industry a more practical answer. It says, the future may not be a car that suddenly sprouts wings in the middle of a busy road. The future may be a smart ground vehicle that carries an aircraft to the right place, then lets it fly when conditions are safe. That is less dramatic than a movie scene, but it is much more believable. And in transportation, believable usually wins. But XPeng is only one part of the story. The other name that matters is EHang. EHang has become one of the most important companies in the global air taxi race because it is not only showing prototypes, it has been moving through certification. That is the key word, certification. In aviation, a flying machine is not impressive just because it flies once. A prototype can fly, a drone can fly, a stunt vehicle can fly. The real challenge is proving that it can fly safely, repeatedly, under rules, with passengers, and with oversight. That is where China's air mobility push becomes serious. EHang's EH216-S is a pilotless passenger-carrying eVTOL, meaning it can take off and land vertically using electric propulsion. It is designed for short-distance flights, tourism routes, demonstration services, and eventually urban air mobility. The most shocking thing for many people is that there is no traditional pilot inside. The passenger is not meant to become a pilot. The aircraft uses autonomous systems, route planning, monitoring, and centralized controls. That changes the entire business model. Because one of the biggest limits in aviation is the pilot. Pilots need years of training. They are expensive. They need rest schedules. They create operational limits. But if a certified system can safely fly passengers without a pilot on board, the economics start to change. Suddenly, the idea of air taxis becomes less impossible. Not easy, not cheap overnight, but less impossible. This is why China's low-altitude economy matters so much. The phrase may sound technical, but the idea is simple. Low-altitude airspace means the layer of sky close to the ground, the space that could be used by drones, air taxis, emergency aircraft, inspection vehicles, and cargo delivery systems. China sees that space as an economic opportunity. If roads are crowded, use the air. If cities are growing, create new transport layers. If delivery networks are under pressure, use drones. If tourism needs new experiences, offer scenic air routes. If emergency responders need speed, give them direct aerial access. In other words, flying cars are not just toys for rich people. They are part of a bigger national strategy, and that is where China may have an advantage. Western countries often move slowly, because aviation rules are strict, city planning is complex, and public acceptance is uncertain. That caution is not foolish. Aviation safety exists for a reason. But China's system can coordinate industrial policy, local government incentives, manufacturing capacity, and infrastructure trials more aggressively. That does not guarantee success, but it does mean China can test the market faster. And speed matters, because the first country to build the standards, landing sites, operating rules, supply chains, and customer trust may shape the entire global industry. Think about electric cars. For years, people laughed at the idea that EVs could challenge petrol vehicles. Then battery costs dropped, charging networks expanded, governments changed policy, consumers became familiar with the technology, and suddenly the question changed from, will EVs work, to, who will dominate them? Flying vehicles may follow a similar path, but with one huge difference. The safety threshold is much higher. If a car breaks down, it pulls over. If an aircraft fails, the consequences are far more serious. That is why the flying car revolution will not happen just because one vehicle looks cool. It will happen only if four things come together. First, the aircraft must be safe. Second, the cost must fall. Third, the infrastructure must exist. Fourth, regulators must trust the system. Let's start with safety. When people hear pilotless flying taxi, their first reaction is usually excitement. Their second reaction is fear. And that fear is reasonable. What happens if the battery fails? What happens if a rotor stops? What happens if the weather changes suddenly? What happens if another drone enters the route? What happens if the communication system drops? These are not small questions. They are the questions that decide whether this technology becomes mainstream or stays limited to controlled tourist flights. That is why redundancy matters. A serious eVTOL cannot rely on one motor, one battery pathway, one control system, or one sensor. It needs backups. It needs emergency landing logic. It needs monitoring. It needs protected flight corridors. It needs maintenance standards. And most importantly, it needs public confidence. People do not need to understand every line of code inside the aircraft, but they do need to believe that the system is safer than the fear in their head. That is one of the hardest challenges in this entire industry, because a self-driving car can make people nervous. A self-flying aircraft makes people feel even more vulnerable. You are not just trusting software. You are trusting software while suspended in the air. That is a completely different emotional barrier. Now let's talk about cost. A lot of viral flying car videos make it sound as if everyone will soon own one. That is unlikely in the near future. The first wave of flying vehicles will probably not be owned by ordinary families. They will more likely be used by tourism companies, emergency services, high-end shuttle operators, airports, business districts, logistics firms, and local governments. Why? Because aircraft are expensive, batteries are expensive, certification is expensive, maintenance is expensive, insurance is expensive, landing infrastructure is expensive. Even if manufacturing improves, the operating cost will still be much higher than driving a normal car. That is why the early market may look less like everyone buys a flying car and more like, you book a short aerial ride in certain locations. Imagine a tourist route over a scenic area, a 5-minute flight across a bay, a quick connection from an airport to a business district, a rescue vehicle reaching a remote area, a medical delivery drone carrying urgent supplies. These are the use cases that make sense first. Daily commuting for millions of people may come much later, if it comes at all. And that is where the hype often gets ahead of reality. The future is exciting, but it will not arrive evenly. Some cities will test it, some governments will support it, some routes will become commercial. But ordinary skies filled with personal flying vehicles, that is a much harder future. Now let's look at infrastructure. A road vehicle needs roads, traffic lights, parking spaces, fuel stations, repair shops, insurance systems, and driving rules. A flying vehicle needs its own version of all of that. It needs takeoff and landing sites. It needs charging systems. It needs weather monitoring. It needs air traffic management. It needs emergency landing zones. It needs noise standards. It needs digital maps of buildings, wires, towers, restricted areas, and flight corridors. This is why the flying vehicle race is not just about who builds the best aircraft. It is about who builds the best ecosystem. A company can create an amazing eVTOL, but if cities do not know where it can land, it cannot scale. If regulators do not approve routes, it cannot operate. If passengers do not trust it, it cannot make money. If insurance companies do not price the risk, businesses cannot expand. And if batteries do not improve, flight range remains limited. This is the difference between a viral demo and a real transportation system. A demo needs applause. A transportation system needs boring things: permits, maintenance logs, charging plans, route approvals, safety audits, and emergency procedures. That is not as glamorous, but it is what makes the technology real. China understands this. That is why the phrase low-altitude economy is so important. It reframes flying vehicles as part of a broader economic platform. Not one machine, not one viral product, a whole new industry. Now, let's compare China's approach with the West. In the United States and Europe, aviation regulators are extremely cautious. Companies like Joby, Archer, Lilium, Volocopter, and others have spent years developing electric aircraft, raising money, testing prototypes, and working through certification. The West has strong aviation experience, deep engineering talent, and mature safety systems. But it also has slower approval processes, fragmented city rules, public opposition risks, and expensive manufacturing. China, meanwhile, has massive EV supply chains, battery production, drone manufacturing experience, and local governments eager to develop futuristic industries. That combination is powerful. It does not mean China has already won, but it does mean China can move quickly from prototype to pilot program to commercial trial. And that speed may shape public perception. Because when people see something flying in real cities, even on limited routes, it starts to feel real. The psychological shift matters. First, people say, that will never happen. Then they see a test flight. Then they see passengers. Then they see a commercial route. Then they say, maybe I would try it once. That is how new transport systems enter the public imagination. Not all at once, step by step. The first flights may be short. The first customers may be tourists. The first routes may be carefully controlled. But every safe flight makes the next one easier to accept. Now, there is another reason this story is bigger than flying cars. It is about national power. Transportation technology has always shaped global influence. The country that mastered railways gained industrial power. The country that mastered automobiles built giant manufacturing empires. The country that mastered aviation gained military, commercial, and logistical advantage. The country that mastered EVs changed the future of the car market. So what happens if China becomes the first country to scale low-altitude mobility? It could export aircraft. It could export battery systems. It could export traffic management software. It could export landing infrastructure. It could export standards. And standards are powerful. Because once other countries build around your technology, your influence grows. This is why the flying vehicle race is not just a tech story. It is an economic story. It is an industrial story. It is a regulatory story. And it is a geopolitical story. The question is not only, will people fly to work? The question is, who will define the next transportation platform? But let's be realistic. There are serious barriers. Battery energy density remains a major issue. Electric aircraft need enormous power for vertical takeoff. That limits range. It limits payload. It limits flight time. It also creates charging challenges. Weather is another problem. Small aircraft are more sensitive to wind, storms, rain, and visibility conditions than large commercial planes. Noise is another issue. Even electric rotors are not silent. If hundreds of aircraft fly above dense neighborhoods, people may object. Then there is privacy. People may not like aircraft constantly moving above homes, schools, offices, and public spaces. And then there is safety perception. One accident could slow the entire industry. That is the harsh truth. Emerging transport systems are judged by their failures. 1,000 successful test flights may create progress. One dramatic crash may create fear. So companies and regulators must move carefully. This is why the best future for flying vehicles is not chaos in the sky. It is controlled, mapped, monitored, and limited air mobility. Specific routes, specific heights, specific landing zones, specific weather conditions, specific vehicle types. That may sound less exciting than total freedom, but it is much safer. And safety is what makes scale possible. So what could the next decade actually look like? In the early stage, we may see sightseeing flights in selected cities, then airport shuttle routes, then emergency response use cases, then cargo and medical deliveries, then limited passenger corridors, then larger networks connecting business districts, transport hubs, islands, tourist zones, and difficult terrain. The first customers will not be everyone. They will be people and organizations willing to pay for speed, novelty, or necessity. But over time, if manufacturing improves and operations become routine, prices could fall. That is when the technology becomes truly disruptive. Not because everyone owns a flying car, but because aerial mobility becomes available as a service. You do not own the aircraft. You book the ride. Just like people do not own trains, planes, or taxis. They use them when needed. That may be the more realistic future, and it is still revolutionary. Think about a city where a 90-minute road journey becomes a 12-minute aerial ride. Think about islands connected without bridges. Think about emergency doctors reaching accident scenes faster. Think about cargo crossing mountains without trucks. Think about rural communities linked to hospitals. Think about disaster zones receiving supplies when roads are blocked. That is where flying vehicles could matter most, not as luxury toys, but as tools that solve real mobility problems. And that brings us back to China. China's advantage is not only that it can build impressive machines, it is that it can connect industries quickly. EV batteries, drone software, manufacturing scale, government planning, urban infrastructure, tourism zones, digital payments, smart city systems. When those pieces connect, a futuristic technology can move from concept to service much faster. But the world should not confuse speed with certainty. China still has to prove that these vehicles can operate safely at scale. It has to prove that passengers will pay. It has to prove that cities can handle the noise and air traffic. It has to prove that maintenance systems can keep up. It has to prove that autonomous flight can earn public trust. The future is not guaranteed, but the direction is clear. The sky is becoming a serious transportation frontier. For over a century, cities expanded outward with roads, then upward with skyscrapers. Now the next question is whether they can expand into low-altitude airspace. That is the real story behind China's flying vehicle boom. It is not just about a cool aircraft. It is about whether the city of the future has 3 dimensions of movement instead of 2. Roads below, buildings around us, and controlled air routes above. If that happens, transportation changes forever. Not overnight, Not everywhere, not without risk, but permanently. The first generation of these vehicles will be expensive, limited, and carefully controlled. The second generation may be safer, quieter, and more efficient. The third generation could become normal enough that people stop calling them flying cars at all. They may simply become another form of transport. Just like elevators once seemed terrifying, just like airplanes once seemed impossible, just like electric cars once seemed unrealistic, technology becomes ordinary, one safe use case at a time. And that is why China's flying vehicle race matters. Because the winner may not be the company with the flashiest prototype. The winner may be the country that makes the sky feel ordinary. That is the real revolution. Not flying for the sake of flying, but making flight useful, repeatable, safe, and accessible enough to become part of daily life. So the next time you see a video of a flying car lifting off in China, do not just ask, "Is that real?" Ask a bigger question. Who is building the landing pads? Who is approving the routes? Who is writing the safety rules? Who is manufacturing the batteries? Who is training the operators? Who is collecting the flight data? And who will own the sky economy when this technology grows up? Because the future of transport may not be decided by the car companies we already know. It may be decided by the companies and countries that understand one simple truth. The road is crowded, the sky is open, and China is moving fast. If you enjoyed this breakdown, hit like, subscribe, and tell us in the comments, would you trust a pilotless flying taxi? Or would you rather keep your feet on the ground? Thanks for watching, and we'll see you in the next deep dive.